Hello everyone, I welcome you all back with my new video. In this video we are going to have a look at new exercise from the arithmetic progression chapter, that is exercise 9.2, which is going to be the continued part of arithmetic progression chapter. Let us see one by one what are different types of questions that have been asked in this exercise. The first question says that show that the sequence defined by an is equal to 5n minus 7 is an AP and find its common difference. In the previous exercise we have seen nth term was given and we were asked to form the sequence using that nth term, and we saw that some of those sequences were not forming arithmetic progression. Here they are telling us that show that this sequence is going to form an arithmetic progression, and then we have to find its common difference. So in order to form the sequence we have to find first, second, third term and so on. So let us do it one by one, as we already know, which is given that an is equal to 5n minus 7. Now to find the first term I will replace n by 1, which will give me the first term, that is nothing but 5 into 1 minus 7 is equal to minus 2. Similarly I can find second term as a2 is equal to 5 into 2 minus 7, which gave me answer as 3. Similarly third term I can have as 5 into 3 minus 7, which gave me 8. Now these three terms are more than enough to identify whether it is going to form an arithmetic progression or no. We can verify that, as you have already studied in previous exercise, by calculating common difference d considering any two consecutive numbers. So first I will calculate d taking two consecutive numbers that are a1 and a2. Therefore we know that d is equal to a2 minus a1. Therefore I can find it as a2 is 3 and a1 is minus 2. Therefore 3 minus of minus 2 will give me 5. Let us find one more d using a2 and a3 term, that is a3 minus a2. a3 is 8 and a2 is 3. 8 minus 3 is also going to give me answer as 5. Since both the common differences are matching, which is being calculated considering different consecutive numbers of the same sequence, we can conclude that this sequence is going to form an arithmetic progression whose common difference is going to be d is equal to 5. Next question is show that the sequence defined by an is equal to 3n square minus 5 is not an AP. As we solved the first example, similarly we are going to solve this by finding first three terms of this sequence and going to check whether it is going to form an arithmetic progression or no. Let us do that. Given an is equal to 3n square minus 5, this is going to be the nth term of this particular sequence. I will calculate first term, that is a1, by replacing n by 1, which give me 3 into 1 square minus 5, that is nothing but 3 minus 5 will give me minus 2. Second term I am going to get as a2 is equal to 3 into 2 square minus 5, which is going to give me 7. Similarly third term a3 is equal to 3 into 3 square minus 5, which is going to give me answer as 22. Now if I want to find common difference considering these three terms of the sequence, as we already know how to do that, that is nothing but d is equal to a2 minus a1. When I do this, second term is 7 and the first term is minus 2. So 7 minus of minus 2 is going to give me answer as 9. Similarly, if I find common difference considering other two consecutive numbers, that is a2 and a3, that is d is equal to a3 minus a2, I am going to get the answer as 22 minus 7, which is giving me 15. You can see here two common differences, means difference found using two different consecutive numbers are not matching. I cannot call it as also a common difference. Therefore this sequence is not going to form an arithmetic progression, as d1 is equal to 9 and d2 is equal to 15. They are not same, therefore it is not going to form an arithmetic progression. One more hint I can give you to identify whether any given sequence is going to form an arithmetic progression or no is if any given nth number is containing terms like n square, n cube, any term whose degree is greater than 1 will never form an arithmetic progression. This one thing you have to remember always. Next question is third one. The general term of a sequence is given by an is equal to minus 4n plus 15. Is the sequence an AP? If so, find its 15th term and the common difference. Remember, as I gave you a small hint in the previous example, you can see here the degree of n here is nothing but 1. Therefore, this sequence will definitely form an arithmetic progression, and he is asking me to calculate 15th term and the common difference. Common difference we know how to calculate already in the previous example. In order to find the 15th term, that is A15, I want first term, that is A1, which I can calculate using this given nth term, and n we already know that is nothing but 15, and if we have the common difference we can easily find 15th term. Let us go ahead and find how we can do that. First of all, let us note down the given data, that is an is equal to minus 4n plus 15. Now using this I will first calculate first three terms of this sequence, that is a1 is equal to minus 4 into 1 plus 15, which is going to give me minus 4 plus 15 is nothing but 11. Similarly, second term I will find a2 is equal to minus 4 into 2 plus 15, that is nothing but minus 8 plus 15 is going to give me 7. Similarly, a3 is equal to minus 4 into 3 plus 15. This is going to give me minus 12 plus 15, nothing but 3. Now I will calculate the common difference to verify whether it is going to form an arithmetic progression or no. For that I will do d is equal to a2 minus a1, that is nothing but 7 minus 11 is equal to minus 4. Similarly, I will consider other two consecutive numbers, that is a3 and a2. Let us find common difference again. D is equal to a3 minus a2, that is 3 minus 7. Again I am going to get the same answer as minus 4. Since both the differences are matching, which is calculated using two different consecutive numbers, I can declare this sequence is going to form an arithmetic progression. Not only this, he has also asked me to calculate 15th term of this AP. Now I already have first term, that is a1 is equal to 15, and common difference d is equal to 5. Using these terms I can find 15th term, that is going to give me a15 is equal to, there are two ways by which I can calculate 15th term. First of all, using this nth term, that is an is equal to minus 4n plus 15, I can directly substitute n value as 15 and I can calculate 15th term, that is minus 4 into 15 plus 15, which is going to give me minus 16 plus 50, that is nothing but minus 45. Or one more formula we have, that is an is equal to a plus n minus 1 into d. Using this formula also we can calculate. Wherever n is there I will substitute 15, wherever a is there I will substitute the first term of this sequence, and wherever d is there I will substitute the common difference we have just calculated. Now when I solve this, 11 plus 15 minus 1, that is 14 into minus 4, that is minus 56 into minus 56 plus 11 is also going to give me the same answer, that is minus 45. Therefore 15th term of this sequence is going to be minus 45. With this we are going to end this exercise. There were only 3 problems given in this exercise. I will come back with a new exercise in the next video. Hope you all are going to enjoy this video and next video as well. Till then, have a good day. Thank you for watching the video.